Hey guys, welcome to your video note 6.6, Systems of Linear Inequalities. So now we have systems of linear inequalities which are made up of two or more linear inequalities. The solution of a system of linear inequalities is a point that makes all the linear inequalities true. So we could check that algebraically, which we're not for these practice problems, but what we can do is graph them here and see what the solution set looks like. So for my first line, I know that my slope is -3 and my y-intercept is at -2. So I'll start by plotting that boundary line. Starting here at -3 or -2, my y-intercept, and I'll go down 3 over 1. Going back up, I'll go up 3, back 1. Up 3, back 1. So now, since it's equal to, I'm going to have a solid line going through those points. And then for my shading, since I want less than, that's going to be shading below that line. So y values below that line would be ones on this side, there and below. Okay, so now for my next equation or inequality, I see that this has a slope of 1 and a y-intercept at 0, because you can look at this as being x plus 0. So I will start at the y-intercept of 0, and I will go up 1 over 1, up 1 over 1, all the way up, and all the way back down, the opposite way. So now here, this is not equal to, so I'm going to use a dashed line to connect those points, showing that it's not equal to the boundary line. And I want less than again, so that's going to be below the line. So I'm going to shade everything below that line. Now, our solution set, if I wanted to make it more obvious if possible, it's everything shaded here, right? With a dashed boundary line on this side and a solid boundary line on this line, on that side. So now they want us to list a few possible points that fall in the solution set. So what could I use? Well, first, this point on this boundary line, since it's a solid line, it's included, and that point is 0, -2. Another point on the boundary line that would work, I believe that's 1, -5. What about a point on this boundary line? Nope, cannot include it because it's dashed, but I could include this point in the shaded region, and that point is -2, -3. Let me pick one more. How about this point right here in the double shaded region? -2, -4. All right? And we could continue to pick a bunch of points that are possible solutions. So the solution set is everything on the boundary line or shaded in between.